Hello and Namaste. In continuation with the complex integration topic Cauchy's integral theorem, we are dealing here with the problems. After the detailed flow chart, so we are using here the different parts of the flow chart according to the demand of the question. Use Cauchy's integral formula to evaluate integration of sin pi z square plus cos pi z square upon z minus 2 into z minus 3 dz, where c is the circle mod of z equals to 4. Now if you'll observe here, first thing we have to do it as the first of all we have to say that denominator equals to 0. So denominator equals to 0 will give us 2 points, z1 equals to 2 and z2. Actually it is a z2. z2 is equals to 3. Now we have to check whether this z1 and this z2, 2 and 3, whether these points are lying inside or outside for particular circle mod of z equals to 4. Now mod of z equals to 4, mod of z, which is same as mod of z1. So we are putting the value of z. So we are replacing the value with the value of z1 and z2. So mod of 2 is coming out to be 2, which is less than 4. That means what, this particular point z1 is lying inside this particular circle. Similarly, if you observe mod of z, that is mod of 3 is less than 4, that means this z2 is also lying inside this region. If both the points are lying inside, and if you observe here, if you wanted to go and check with the circles also, this particular circle using this the equation of a circle with center at a comma b and radius as small r, is mod of z minus a plus ib is equals to r. So we have just already done this particular type of introduction from this Cauchy's integral, Cauchy line integral. So please follow this I button so you can just reach to that particular section or session. So this is also one of the way to show the pictorial way, that is this point 2 and 3, because the radius of this particular circle is 4. Radius is 4. So obviously this z equals to 2 and z equals to 3 will be the part which are both of them are inside this region. So we have got two different methods to show that or to check that whether the point lies inside or whether the point lies outside this particular circle. Now moving ahead, we have got this z1 and z2, both of them are inside. So we have got the type 2 because we have got more than a point. So z1, z2, both of them are inside. If both of them are inside, we have to go for the partial fraction of this kind and calculate this k1 and k2, or find out this k1, k2, and you can go ahead with the 2 pi I times k1 f of z1 plus k2 f of z2. Let us go ahead and make this particular type 2 part C. Type 2 part C would be the application, or you can say this particular formula can be applicable in this scenario. Why it's applicable? Because both the points are inside in this particular circle. Okay, so that means what, we have to go for the partial fraction. Partial fraction will not include the numerator of this particular function or particular integral. We have to just go ahead with 1 upon z minus 2 into z minus 3. Now this is z to the power 1, z to the power 1. That means what, we have to go hiding method just to say a and b. Now if we wanted to go and find out the value of a, it is if z is equals to 3. Then numerator and the denominator we have to put it, but we cannot put it here. We have to put it only in the first bracket, and we are going to get the value of this a is equals to 1 upon 1, that is 1. If z equals to get this value of b to z equals to 2, then what will happen? We have to not put it here, we have to put it here. In that case, we will be getting the value of b as minus of 1. So we got it as minus 1. So we can have this 1 upon z minus 3 minus 1 upon z minus 2, and that would gives us this particular fraction. So we have done the partial fraction over here. So if you'll observe here, k1 in this case, k1 is equals to 1 and k2 is equals to minus of 1, which are the values of a and b. So now here in numerator is nothing but f of z, as we have said it here. F of z is nothing but the numerator, sine of pi z square plus cos of pi z square, which will be giving. So we have to find out these 2 points, like f of this z equals to 3, so z2 and z1. So f of 3 is sine of pi 3 square. So we have to replace z by 3. After replacing z by 3, we are getting sine of 9 pi plus cos of 9 pi is equals to minus 1, and that is because of this fact, that is cos of n pi is minus 1 to the power n. Sine of 9 pi will move to 0, but cos of 9 pi is nothing but minus 1 to the power n. N is 9 in this case, so we are going to get it as minus of 1. Same way we are going to go ahead with f of 2, that is sine of pi 2 square plus cos of pi 2 square, that is this. Again this sine of 4 pi is going to be 0 and cos of 4 pi is nothing but minus 1 to the power 4, that is plus 1. So we got these values, and using this particular formula, as I have told here already, that is 2 pi I into f of 3 plus minus 1. So this is k1, this is k2, f of 2 and f of 3, replacing it, we are going to get the final answer as minus 4 pi I as this particular question. So this is all about the type 2 part C. Evaluate integration 7z minus 1 upon z square minus 3z minus 4, where C is the ellipse x square plus 4y square is equals to 4. If you'll observe this particular ellipse, we can adjust it and we can have it at the small a and the small b value, that is x square upon 2 square plus y square upon 1 square is equals to 1. If you'll observe this particular ellipse, it will be 2 at x axis and 1 as y axis, or you can say here minus 2 here and a minus 1 here. So this type of setting or this type of ellipse, we are going to get it from this particular equation. Now let us talk about the denominator equals to 0. Denominator is z square minus 3z minus 4 is equals to 0. That is z minus 4 into z plus 1 is equals to 0. That is z1 is 4 and z2 is minus 1. So if you observe here, z1 equals to 4, that means what, 4 plus 0 times I. That means this z1 point would be somewhere here on the x-axis. And if you observe, this is the 2 and a minus 2, that means what, this 4 will be somewhere here, which is obviously outside. This is using the pictorial graph we can just talk about. Then z2 would be minus 1, which is minus 1 plus 0 times I, that means again it would be somewhere on the x-axis, and that is the part here. So if you'll observe here, this point is inside. So that means z1 is out and z2 is in. So we have got a combination of these two. So one point is outside, one point is inside. In that scenario, we have to go ahead with the type 2 part E, where is one point is outside, another point is inside. We have to, it's just a caption, or you can say a labels for this. You have to understand that the point which is outside, we have to club that with the numerator and form the function f of z, and you have to find out the value of that function at the point z2, which is the inside point. Now here in this case, we have got z1 is out, z2 is inside, the same way what we have been given here in the type 2 part E. So therefore f of z would be 7z minus 4 upon z minus 4, because this point z1, that is 4, is outside. So we are combining that z minus 4 with the numerator. We are going to get it as f of z. So f of minus 1, so the point which is inside, that is minus 1. So we are finding out the f of minus 1 as we got it as 8 by 5. It's a simple, so every z we are replacing here with minus 1. We got f of minus 1 as 8 by 5, and therefore in this way, the way I have shown you here, the same way I have to do it here in this case. So it is nothing but 7z upon z minus 4, as this is the f of z, right? I have written it here. So it is f of z upon z minus z plus 1 dz. This is the same setting what we have got it here, and therefore it is nothing but equals to 2 pi I into this, which is equals to 16 pi I upon 5. So this is what we got it as, this particular answer, where one point is in, one point is out. Type 2 part E. Use Cauchy's integral formula. Evaluate z plus 1 upon z cube minus 2z square dz over the curve C. C is the circle mod of z minus 2 minus I is equals to 2. Now again, this particular circle means what? According to this equation of a circle with center at a comma b and radius small r, that is this, we can draw the circle, or you can say that circle with the center 2 comma 1 and radius is equals to 2. That means here we can get it here, denominator equals to 0, so z cube minus 2z square is 0, that is z square into z minus 2 is 0. That means z1 is 0 and z2 is 2. But if you observe here, this z1 equals to 0, but it is having the power 2. That means what it is, this particular value is getting repeated, this particular value repeated 2 times. Okay. That means this type of circle we are going to get it using this particular pictorial. So we have to take a decision which point is in, which point is out. Now if you observe, z1 is equals to 0. This particular point, if you observe here, this is the origin which is lying out. So this is the point which is outside. Z2 equals to 2 is nothing but the 2 comma 1, That means here is the point. You could observe here, this point is inside. This we can show it pictorial. Otherwise, if you wanted to have it in the way which we have done it previously, that is checking the distance from the origin, checking the distance of a point from the origin, that is put the z or replace z using the point. So z minus 2 minus I is the equation of a circle, which is equals to replacing z by z1, which is 0 minus 2 minus I, that is square root of 5, which is going greater than 2. That means this origin, or you can say the point origin, is lying outside. Similarly, this particular point z2, which is 2 minus 2 minus I, that is 1 is less than this. That means this point is inside this particular circle. So z1 is out, z2 is in. So again we have got a combination of this particular type, that is type 2 part E. Again we have to do the same thing, put this particular phi of z and form f of z. So f of z is numerator divided by the point, which is z square, because it is repeated. And therefore if you'll observe here, we have to find out the value of f of z2, that is f of 2. F of 2, the value of f of 2 is 3 by 4. Therefore this type of setting we require the way which we have written it here. And therefore the final answer is 2 pi I into f of 2, which is equals to 3 by 2 times pi I. Because f of 2 is 3 by 4 and this 2 and 4 will have the, so it's 3 pi I by 2 is the answer for this particular question. Again we have applied the type 2 part E, because one point is outside, one point is inside. Evaluate integration z plus 4 upon z square plus 2z plus 5 dz, where c is the circle mod of z plus 1 plus I equals to 2. Using Cauchy's integral formula, so this is the circle. If you observe here, the circle is the center with minus 1 comma minus 1 and the radius is equals to 2. If you observe this type of circle, we are going to get it. Now we have to say that denominator equals to 0. After taking the denominator equals to 0, we got the two roots. Z1 is minus 1 plus 2i, Z2 is minus 1 minus 2i. If you wanted to see that pictorially, you can easily check that center of the circle is minus 1 comma minus 1 and the radius is 2 unit. And if you observe the point minus 1 comma minus 1 minus 2i is the point inside, wherein minus 1 plus 2i is the point outside. Let us check that with the same way, the distance between the center of the circle and the point. So this is the replacing z by z1, that is minus 1 plus 2i, plus 1 plus I will be mod of 3i, which is going to get it 3, which is greater than 2. So this particular point is outside the circle C. Similarly, the other point minus 1 minus 2i is, if you will observe here, just check the calculations, you will get this point is inside. So again we have got the combination of in and out, type 2, and out of that the part E, that is z1 is out, z2 is in. Again we have to form here, the set of this f of z, that is z plus 4 upon z minus z1. Now we have to have f of z2. Purposely I have taken this z1 and z2 here because of the values there are so many plus minus sign, minus 1 plus 2i, minus 1 plus 2i, minus 1 minus 2i and so on. That's the reason first take care of that. Put the labels z1 and z2. Understand the concept that f of z is z plus 4 upon z minus z1, the point which is out here. So z1 is the point which is out. Therefore we have to find out the value of the function at the point in, that is z2. So f of z2 is z2 plus 4 upon z2 minus z1, that is minus 1 minus 2i plus 4. There is no this is, please ignore this. So divided by minus 1 minus 2i minus of minus 1 plus 2i. And we'll be getting the value as 3 minus 2i upon minus 4i. This is the value for f of z2. Again the same setting, what we have done it here, and we'll be getting the answer as minus pi by 2 into 2 minus 3i as the answer for this particular question. This is what is the answer. We are going to get it again, type 2 part E. And every time we are dealing here with a different type of questions and different set of values we are going to go ahead with. Then evaluate integration z dz upon z minus 1 into z minus 2 the whole square, where c is the circle mod of z minus 2 is equals to half, using Cauchy's integral formula. Again the equation of a circle, then the center at 2 comma 0 and the radius half. The denominator equals to 0, z1 is 1 and z2 is 2. checking with the distance here, actually it's z1, which is 1. I mean mod of z1 minus 2 is coming out to be 1, which is greater than 2. That means what, this particular point is out. Then this particular point, if you see this is 2 minus 2, 0, that is, this point is coming out to be in. That means again we have good. So if you see this pictorially, it is nothing but the center at 2, 0, radius is small half, I mean it's a half, it's a very small circle, and at that point, this particular point 1 and 2. So if you observe here, 1 is out, 2 is inside this circle, and that is what we got it as the by this also. So again, type 2, part E. This we have to deal with the part 1, this part type 2 and part E. Now f of z is coming out to be z upon z minus 1, the point which is out. But here another formula is also getting included, because of this part 2 is repeated 2 times. So if you observe here, z minus 2 the whole square. Because of this part, that means this z2 is repeated, is the value repeated 2 times. That means what, we have got this z minus 2 the power 2. That is z minus z0 to the power n. This type of scenario will exist. So we have to make use of 2 different types. So type 2 and type 1. Under the type 1, we have to go with the b, which is point is inside, and we have to go with the formula for the derivative. This is what, 2 pi I upon n minus 1 factorial, n minus 1th derivative of f at the point z0. And therefore f of z is z upon z minus 1. We have to take the differentiation of that. That is coming out to be minus 1. So it's a simple u by v formula, minus 1 upon z minus 1 the whole square. And therefore f dash of 2, the point which is in, we have to find out the value of that. So f dash of 2 is coming out to be minus 1, and hence the final answer is coming out to be minus 2 pi I. And because here it is n minus 1 factorial, in the present case n is equals to 2. So it's 2 minus 1, 1 factorial, which we have written it here already, and 2 minus 1, that is first differentiation we have to go ahead with. This is what is all about. The 2 different types have included in this particular question. So again, this question gets separated as that of the previous questions. Again, this is a different type of questions. If f of a is equals to 3 integration 3z square plus 7z plus 1 upon z minus a dz, where c is the circle, mod of z equals to 2, find the values of f of 3, comma f dash of 1 minus I and f double dash of 1 minus I. First of all, we have to note that is in the Cauchy's integral formula, f of z was used to denote the numerator of the integrand, and integration f of z upon z minus a dz equals to 2 pi I into f of a. But in this problem, f of a is used to denote the value of the integral. So here normally we are using this as this point, right? This is f of a. But here in this case, they have used that as a value of the function, or your value of this particular integral. Now f of a is phi of z upon z minus a dz, where phi of z is the numerator, that is 3z square plus 7z plus 1. Now talking about this point 3, because we have to find out the value at this 3, value at this particular value at 3. So if I wanted to have the value 3 here, that means mod of z is 3, mod of 3, that is 3 greater than 2, that means what, this particular point is going out. If this particular point is going out, if you observe here, you can check it very well here, which is the center of the circle. Mod of z equals to 2, center is 0, 0, and the radius is with 2 unit here. So the radius is 2 unit here. So you can check it, z equals to 3 is lying outside, and if it is lying outside, type 1, and out of that capital A, that is z0 is outside. If it is outside, by Cauchy's integral theorem, the value of the integral becomes 0, and hence we can have it, the value of this particular f of 3 is equals to 0. So we are going to get the value of this is equals to 0. So in short, what we have to do it here, we have to replace this as 3. So a is nothing but 3. So if you observe here in this 3 is, this is 3. So that means it has been given to us 3z square plus 7z plus 1 upon z minus 3 dz. That is what we got it as the point 3, and this 3 point is lying outside. If it is outside, the type 1 a outside, into the value of the integral becomes 0. Moving ahead with the next way, So f dash of a is integration phi of z upon z minus a the whole square dz, that is 2 pi I upon 1 factorial phi dash of a if the point a is inside the C. This is what we have seen the formula. Now again the type this type 1 part B, which is z0 is inside. If it is inside, then we have to use this particular formula. Check this, 1 minus I is square root of 2, which is less than 2. If it is less than 2, that means point 1 minus I lies within the C, and therefore we can get it the value as. So that means what, we have to find out the differentiation first. So this is nothing but f dash of 1 minus I is 2 pi I into d upon dz of this particular function, which is coming out to be 2 pi I into 6 times 1 minus I plus 7, which is 2 pi into 6 plus 13 times I. This is what we got it here as the value. Same way, f double dash of a is coming out to be here, you can say here the cube value here is cube, and therefore the particular formula will move as 2 times integration phi of z upon z minus a the cube dz is equals to 2 into 2 pi upon 2 factorial phi double dash of a. The same way we can go ahead 2 times differentiation of that, and we after 2 times differentiation will be getting the value as this 12 pi I of this particular. So again, this type of question, this type of setting is different. It is according to the demand of the question we have to apply it. Okay, and this is all about the self-observation slide wherein 1, 2, 3 questions has been given along with the answers. Please do solve these particular questions. If at all any question, write me in the comment section. I hope you have understood the concept of complex integration in detail. Thank you so much. Happy learning!